So far, we have only included linear relationship in our discussion. However, in the real world, relationship between variables are not linear most of the time. And so we have to incorporate nonlinearities in our regression model. So let's look at this example here. We've got a model that explains how much education affects a person's wage. So we've got wage equals to 0.9 plus 0.54 education plus U. So that means that an extra year of education would increase your hourly wage by 54 cents. And it's not very realistic because whether you're graduating high school or you're getting a PhD, it means that no matter what your education level is, you're always going to just get a 54-cent of raise. And that's not very realistic. But now let's look at this equation here. And we've included a log function to the dependent variable. So why did we use this log function here? The log function expresses the percentage change in wage for 1 unit change in education. So here our coefficient is 0.083 education. So this whole model means an extra year of education would increase the hourly wage by 8.3%. So this is more realistic. Whether you graduate from high school or get a PhD, your hourly wage increases by 8.3%. However, this is not an absolute value. This is a relative value. This is relative to your base salary. So the percentage increase is same for a graduate of high school and a person with a PhD. However, their actual salary is going to be very different from each other. So this represents the real world more accurately. So hypothetically, let's assume someone in their fifth year of PhD earns $80,000 per year. So after he got his PhD, his wage is going to increase by 8.3%. That is, he's going to have a $6,640 of increase in his wage. On the other hand, let's say someone in his senior year of high school earns $40,000 per year. So after he graduated high school, he's going to have the same level of 8.3% increase in his wage, and that would amount to $3,320 of increase in his wage. So despite having the same percentage amount of increase in the wage, the actual increase in wage is quite different between a high school graduate and someone with a PhD. And this is more in line with the real world. So the graph here shows that the higher your education level is, your wage is going to increase exponentially. Let's look at another model, and we've got a relationship between salary and sales here, and we've got log function in both the dependent variable and the independent variable. This is a constant elasticity model. Here, the coefficient of the sales is 0.0257. So the model means that the 1% increase in farm sales would increase salary by 0.257%. Now, you may ask that one of the key assumptions of OLS regression is that it's linear. So how come we are including nonlinearity in our model? So we have to note that the OLS regression are linear in parameters. So it's linear in beta 1, beta 2, all these parameters. There are no such restriction for the variables. So we can incorporate nonlinearities in our variables.